Go. Hi everyone, and today we are going to discuss few things at a little faster pace. First one is Sqoop, and then Flume, then Oozie, then little bit we'll touch Mahout. Okay, great. So since most of the data, since most of the data as of today lies in the existing databases, there always was a need of moving the data back and forth between HDFS and existing relational databases. So keeping that in mind, as well as keeping in mind that data is going to be big, Sqoop was designed. So Sqoop is essentially an open source tool that extracts data from structured data sources, okay, structured data stores such as any database or any basically a database, okay, or anything that implements JDBC. All right, and it imports the data into Hadoop for further processing, and after processing it puts it back into, it can put the data back into an RDBMS. Okay, so also you can move the data back and forth between HBase and any database, and you can export the data from any databases. Okay, in case your database is not supported, it comes up with a extension framework, okay, by the way of connectors, so you can customize its behavior, or you can write your own connector using the extension framework. Most likely your database is going to provide JDBC connectivity, and that is good enough for Sqoop. You don't have to write anything else. Okay, so if your database supports JDBC, you are already there. Okay, now, okay, so basically Sqoop is a way for in and out data into the HDFS, Hive, or HBase, okay, from your relational database or to your relational database. Okay, now we have, so let's just for this will, okay, so this is not something related to, cool. Now here we have we'll say Sqoop. Let's see. So Sqoop client is installed on all machines, and if you say Sqoop help, so the font is the font big enough now? All right. So is the font visible enough? Good, good. So basically, Sqoop provides a way of, you know, importing, exporting the database, and import. Import means import a table from database to HDFS. Okay. All right. So you can actually SSH to Hadoop 1, Hadoop 2, Hadoop 3. It will work from all the places. Okay. And since Sqoop doesn't have any server, Sqoop is basically a client library. Okay, so it doesn't matter from which server you, whether you're running it from data node or you're running from anywhere, it will find the Hadoop installation, okay, locally, or you can actually define Hadoop installation, and then it automatically will figure out which one is name node, and then it will work. Okay, and for seeing like what does it mean by Hadoop import, Sqoop import, it will tell you all the details, like what all things you can customize. All right. So let's take a quick example. Let's take a quick example. And so feel free to ask and stop. I mean, I will be moving a little faster. So unless and until you ask a question, I will not be stopping to answer, stopping to wait for your question. Okay. So, uh, but that does not mean that do not ask the question. Okay. Please feel free to ask the question. All right. So Sqoop connector is basically a modular component that uses extension framework. Okay, just like any extension framework of Eclipse, it also comes up with its own extension framework, and you can customize it, but you don't have to generally worry about it. Most of the available connectors are MySQL, Postgres, Oracle, SQL. So if you look at it closely, everything is already covered. Okay, even the third party, little less common ones like Teradata and Netaja are already covered. Okay, so you can fairly assume that SQL scoop connectors you won't have to extend by yourself. Now let's have a quick run. And so let me check if my database is running. Good, it's running already. Good. Now I don't have to run it again. So did it support ODBC? I think it should support ODBC because you can make a connection to any database which supports ODBC via Java. Okay. And all right. So anyway, I'll make a note of it and we'll publish it. I'll find it if it supports ODBC once, and I'll publish it on the forum. Okay. Let me just make a note of it. All right. Now, did it support ODBC? Okay. Now, moving ahead. So what we are trying to do is first, let's create a sample data for you. All right. So what we are trying to do here is we will create some tables and some database in our MySQL. MySQL is already running on this server. We will create a table onto this server, and then so let's create. We logged into MySQL. All right. The password for MySQL is nothing. Okay, but don't fiddle with it too much. Okay, scoop example, let's say we call it. So, all right. All right. We'll call it scoop ex8. Use scoop ex8. Cool. Now, next thing we are going to do is we are going to grant all the privileges on on this. All right. Yes, you can use the MySQL on your local machine. It is just that wherever you are running Sqoop, okay, it should be able to connect to your database as well as it should be able to connect to our HDFS, right? So to make our HDFS available to the Sqoop, you will have to install Hadoop on that machine where you are running Sqoop. Installing Hadoop does not mean you're going to install the server. Installing Hadoop means you are going to install the client, Hadoop client, in which you will mention what is the name node and other things in the config, as well as you will establish the trust between the two nodes, between our servers and your local server. Okay, so it is going to be a little longer process than you would have expected. So it would be easier as of today to use the existing servers itself. All right. So was I able to convey, Cletus? Okay. All right. Now, all right. So we have everything in place. Now let's create a table. Create table widget, and there we go. We have created our table. We say star, select star from widgets, and we say describe widgets. We are in MySQL for time being. Okay, so good. We have all the columns. We have got these columns in place. Now we are adding some values to widgets. All right, let's see what is there in widgets. Good, good. So we have got a widgets table, and all we want as of today is to copy this data onto our HDFS. Okay, okay. So, all right. Yeah. So what do you mean by when you say scoop and so this is basically name of the namespace. Okay, we just created a database called Sqoop EX8. It's basically the name of the database which we are creating, or you can think of it as namespace in which a bucket or a bag and in which you will be putting all our tables. All right. So you can create your own database for this example so that you do not interfere with other people's work. Right? And here we are giving the basically here we are giving the privileges to dot star as in the regular expression, which means all the databases whose name starts with scoop ex. All right, that's what we are trying to do. Cool. Now next, moving on. So we created the database, and now we are in a position to import the data. So next thing is I'll leave the MySQL as is intact. My all right, and all right. I think it will be better to quit it. Okay, now and those of you who do not know, we call it. Okay, I'll keep that demo separate. Okay, because if there is a way to manage your windows and sessions inside Unix so that you so that even if you exit you can switch between the windows, right? I'll show that some other time. Okay, specifically that will be a good approach when you are having separate accounts. We'll have your separate account soon. And okay, now moving to HDFS. Okay, moving to HDFS. First of all, what we are trying to do is we are connecting here. Let me just copy it to the text editor. We are basically importing our whole table into the database. Okay, our whole table into the database. Sorry, what I'm talking about. So here, what we are talking about is for this database, this table we are importing into HDFS. Okay, let's just see what happens. So you can see that it's basically running that also into a MapReduce job. Why? It created multiple MapReduce job which all will be connecting to the RDBMS and importing the data parallelly. Okay. So here probably the other server, Hadoop 2 or Hadoop 3, could not connect over MySQL, and that is why it was not able to connect. Okay, you see, never worry, it will try 2-3 times and then it will work. So it says all of them have failed, and so basically whenever, let me change it a bit. Hadoop1.knowbigdata.com. Let me see what happens now. Telnet Hadoop1.knowbigdata.com and 3306. 3306 is the port. 3306 is the port on which our I'm just trying to check if other data nodes are able to access my MySQL. Hadoop 2 is not allowed to connect to this MySQL, and therefore it has been closed. Oh, this is the reason. So basically, okay. So let me just say Hadoop 8, Hadoop 8. Alright, let's see if that works. Okay, now let me see. Now this guy is able to connect. Alright. So Hadoop 2 is now able to connect happily. Now let's run our example again with Hadoop 1 knowbigdata.com scoop ex this, and let's see what happens. Is it giving the error still? No column generated for the, okay, so it says access denied for the user blank. Okay, most likely I would be making a mistake with respect to the ex, that is right. Sqoop ex8. Sqoop ex8. Okay. Okay. MySQL. Okay. MySQL. Let me. Okay. MySQL minus user root and minus host hadoop1 dot knowbigdata.com. What? Okay, basically some permissioning issues. Okay, that's a separate issue, I think. So I'm trying my luck. I'm trying to see if basically if the task tracker of the local machine is what is being picked up, then it will work. If the task tracker, if the task node or the date checkout spaces. Okay, so now it gave a different error. It says that the output here is already existing. Okay, so let's just remove this file. It says, okay, this already exists, right? Now, if we have Hadoop fs minus rm, all right. Now let's try again. Let's see if we are lucky enough to. Okay, okay, good, good. Now if you see the URL to track the job is Hadoop1, which means we happen to get a slot. Basically, our work is being done by Hadoop1, and our MySQL is also executed on Hadoop1 itself. Therefore, we have already established the trust login and password between Hadoop1 and localhost. Therefore, they are able to fairly connect. But in case the work is delegated to any other database, then it will become difficult. I'm just hoping that it works, because in 99% chances it won't work. Okay. Basically, we'll have to set up our MySQL such that we let's see if I'm just playing a gamble here. Okay. Anyway, it's not working. We'll have to look at some other problem. The driver has not received any exception. Communication link failure. Okay, okay. Basically, it's not able to connect to our database. Let me just see what all need to be done. Okay. Okay. So Naveen was asking something. Can you explain again why this is okay? Right. So there is no reduce involved in this process. It's only the map part. Okay. In this map part, basically, it's running on multiple nodes and getting the data from the database and copying it here. And again, it's not able to connect. Okay. Okay. So is the presentation not available on the portal? Or it's not? Yeah, we have MySQL on Hadoop one. All right. And so let me just give you the presentation for time being, and then you can. So for time being, I'm just copy pasting the link here in this window, and then we can go forward. Right. All right. So Naveen, is your question answered? We have MySQL and Hadoop one running. Yes, Sini. All right. Great. So basically, right now I'm not able to give you a demo, and I mean, yet to figure out why. So when I'm saying JDBC MySQL and the table is connect, I'm basically talking about this. So Naveen's question is, yes, basically I'm wondering how does a map work on a database? Basically, in case of a map will be what exactly the map would be doing is in the map code, what exactly will it be doing is it will be reading, it will not be generating essentially you know the usual way. It will be opening a JDBC connection to the database and reading the data from there and putting it into the file. Okay, I'm putting it into the file. That's all. It will be using a different kind of input split. It will be using a different kind of input split. Right. So it will be having its own input split in which the way we had splitted the file, it will split the rows and give it to each individual nodes, where each individual nodes will just dump it to HDFS file. Okay, so here more than MapReduce logic, it is that input split which will be doing its magic. Okay, have a look at the Sqoop's code. You will quickly figure out that it's not, I mean, though it's a big deal, there are too many things, but with respect to distributed nature, it is basically creating a RDBMS kind of input split. All right. Now, okay, so ideally we generally have we may have made some mistake while defining our database. So I'm trying to use the older one which used to work, but I do not think that it will work. Okay, so it's not able to do much. Okay, so this one has worked. This one has worked. Out of 3 map tasks, 2 map tasks have failed, and the work basically got done at Hadoop 1 instead of other ones. Okay, you can see that on the server. All right, now as you can see now that this is where it has imported the data. So whatever we had on those tables, it is imported here. Okay, and as a comma separated file. All right, And as well as we have got a class called widgets.java, which can be used as a data model. In case you have to keep doing it again and again, and you can use the widgets.java. It contains all the code to read and write. Okay, so it can basically work as a data model for you. All right. So basically, the problems I was facing was with respect to the permissioning of MySQL database. So I used an older database which I had created earlier called Sqoop 2, and then imported that table. And this table which I showed you is under a folder called widgets in a file called part something. Okay. So here you can see, right? So we have part just like any other MapReduce code. In this we have got Hadoop fs minus cat this. Alright, so it's a comma separated file. Now the next step, if you have to again import this file into Hive, you will have to create a table, and the definition can also be imported from MySQL. Okay, the definition of the table can also be imported from MySQL. Therefore, we'll have to run another, we call it, so first we created HDFS file in the first go. Now we are creating, using again Sqoop, we are creating a table in the Hive. Instead of we trying to guess, instead of we trying to create each column by ourselves, we are using Sqoop, which will query our database, query our table in MySQL, and then create that table in Hive. That is what this command is trying to do. Okay. Now, next step, if you are in my place, so what will you do is, okay. So here, what you're going to do is, so we created a Hive table. Okay. We created a Hive table. What's the name of the table? Widgets. And let's see what happens to widgets. Create Hive table, connect, and then show tables. So it by default, whatever is the default database, it creates the table in that. And here you can see there is a widgets table in Hive. And we say, what was the command? Can anybody help me? What was that command? Formatted. Okay. Describe formatted, which tells you exactly what kind of table it is. It says that it's a managed table. What does it mean by managed table? In case you drop the data, of your table of this table, the folder will get deleted. Okay, and the data of this table is going to be located at this place. And right now, let's see. Select star from widgets. Again, we are inside Hive. And this is what we have right now. Okay, delete. This is probably from previous one. Okay, let's just, we want me to drop table widgets. let's just drop the table. Okay, let's just try to create the table again. Good. Now I'm going into Hive. It should have the widgets table created again, and see what is there in the table, and also describe formatted, and we call it describe formatted. Alright, so there is a table called this, and let's see what is there. Select star, select star from widgets. No, it's not there. And also again, let's check. Good. So we have first, in the first set, what we did was we copied the data from MySQL to a comma separated file in HDFS. Now the next step is, and also note that while while our Sqoop created this table, so first we copied the data from MySQL as a comma separate file in HDFS. Second, we created a blank table with the same set of columns as it was there in MySQL. And also note that by creating this Hive table, it has put the same same parameters of like comma separated values, as well as field delimiter is comma, and line delimiter is new line. Okay, for this table. Now when we are importing our comma separated file, which was imported by Sqoop in the first previous command, it is going to be easily imported. Okay, why I'm saying this? Because while creating our any Hive table, we need to specify that when we are importing data into this table, what format the data is going to be. Okay, now the next step is to basically load the data in the path widgets into a table called widgets. Okay, let's go into Hive. All right, now it is imported. Let's see what happens. So the data has been imported. All right, so there were two steps. First was import the data to HDFS file. Second, create an empty table based on our MySQL table. And third was to load the data in the file from HDFS into this table. All right, now instead of these three steps, you could also simply import directly into Hive using this. We could say SQL import connect to this data as well as do the Hive import. Okay, so all of this will happen in a single shot. Sounds good? So if we, let's say we, not this, we go to this and we call it so. Alright, so for this we'll have to drop our table and then work on it. Alright, Okay, so it's saying now in a single step we did all the things in a single shot. All right, now let's keep trying multiple times, and we know the reason why it is so, so nothing to worry. Good. So it has finally, it cried a lot, but it imported the data. We can see that. Select star from widgets. Good. So it did all of this in a single shot. All right. Now, similarly, so here we were successfully able to import data into Hive. On the similar line, you can import your data into HBase. Okay. In HBase, what we are trying to do is we are basically, let me see, we have, so what we are trying to do is we are trying to import this MySQL table into an HBase table called myHBase table and into a column family CF1. Okay, let it try a bit. Let's see what's going on with our HBase is running fine, HDFS is running fine. HDFS is just giving one error, which we know that our secondary name node is down. Oozie is not running, so Oozie will have to start for the later session. Alright, why it is giving so many errors? Alright, so we can test what's going on from here also. So this time the problem with it is cannot access HBase table. Okay, So it has launched 3 maps and no reduce as of now. Can Sqoop import from object database as well? Also, in case of RDMS, how does it deal with reference tables? So in a very simple words, it doesn't deal with reference tables. Okay. It tries to consider the table as the independent entity without any referential integrity. Okay, and regarding object database, I'm not sure if they are connectors, so I'll just make a note of it. I'll just make a note of it. As far as I knew, does it support object databases such as MongoDB? So that I need to check. Alright. So how many errors? Launched 8, failed 8, which means 2 were successful. Okay. Okay, which means at least 2 were successful. So let's say I say HBase shell. Oh, we call scan why can't I get it right in a single shot? So it has imported the data which we were trying to import. All 3 records have been imported here into a column family CF1. Remember, we always create a column family for the database, and here while importing our table from MySQL, what we have said is import this table from our MySQL database, this one, into an HBase table, this one, into a column family CF1, and this is where our table is. Okay, so you can see row number 1, column family C1. At this time, the value is this one, and the column name is design comment, design date, and price. Okay, and then there is something called version, visit name, and all these things. Okay, so this is basically a single row, this is another row, and this is another row. All right, so we were able to successfully import the data into our HBase. And if we have to do a similar thing, if you want to import the data from Hive to MySQL, again you can do the same thing. So say you have got a file Okay. All right. Now, what we're trying to do is we want to show you how to export the data from Hive to MySQL. For that, first we need to create one HDFS file and then load this data into Hive table, this one. And so create a file called sales.log, create a table representing this file in Hive, and then load this data into our Hive table. Once you are done with loading the data into a Hive table, you can basically create a MySQL table, a parallel MySQL table, and afterwards you can export. Okay, afterwards you can export. Now, so here we have Hive. Okay, so let's check if we have already created a table called sales. Cool. So sales is already there, so we don't have to create the sales table. And we want to import this into our MySQL database. And we say show databases. And we say use Sqoop ex2 and show tables. We have widgets table, but not so show tables. Sales is there in the test. Select star from sales. Right now, sales table doesn't have any record. Therefore, we can easily easily import the table into. Alright. So launched map task for Okay, so I think nothing has been imported. Alright, so it seems to work this time. Fingers crossed. It's basically the problem is that we have not allowed other task trackers to access our MySQL, and that is where the problem arises. When the work is distributed amongst these various nodes, they try to connect to our MySQL, and if they fail to connect to MySQL, they start giving error. And if you are lucky and our task tracker is local on the same machine, then we are able to make it work. All right. All we need to do in this case is we need to just give the permission while creating the database. While creating the database, we just need to give the permission properly here. We have given only the permission to the local host. We need to give the permission to others as well. So I need to actually see how exactly does it work. I need to understand in MySQL how can I give these permissions, or how do I establish the login password kind of uh, way between our Sqoop as well as the between Sqoop and MySQL. Okay, so I'll have to see how can I call Sqoop with MySQL user ID and password. Okay, so it's stuck somewhere. And, all right, so I'll finish. Don't worry. All right, so that is how the Hive works. Hive basically helps you doing the data import export between RDBMS and our RDBMS and HDFS HBase Hive. Sounds good? Where is it stuck? Okay, so moving on. Export command basically says that we are trying to, you can see that. So we are saying export connect to MySQL database. Table name is this, and here we are saying have only one mapper. Right? I think yeah. And this is the directory in which our Hive table is stored. Okay, this is the directory in which our Hive table is stored, and we are saying import. Okay, this is the directory in which my Hive tables are stored, and input fields are terminated by comma. All right. Why does it take so much of time? And also note that for every work we are doing, it basically is creating a jar a jar containing maps and reduces for this purpose. Okay. Hi Madhav, your mic is getting, switched on again and again. Okay, kindly turn it off. I'll turn it off right now. Don't worry about it now. Okay, so it's doing something. I don't know what is it doing. All right, never worry. So moving on. So this is how a Hive to MySQL and MySQL to Hive, or and in similar example, we can also do the HBase to MySQL and HBase to MySQL and a HDFS to MySQL in the same way. Okay, this is essentially, if you look at it closely, it's essentially HDFS to MySQL, because here all we are trying to say is this is the directory which contains my file, and this file is essentially a comma separated file, comma separated, new line separated, and that's all right. So as an exercise, you guys should try to run these examples by creating proper database. Try those who are acquainted with MySQL, they can create their database so that it can be accessed by other systems. Okay. And how do you check? If you can, you log in into Hadoop 2. You log in into Hadoop 2, and once you have been able to successfully log in into Hadoop 2, you do MySQL and provide the host name of Hadoop 1 and try to use your database. If you are able to use that database from Hadoop 2, that means you have created your MySQL databases such that they can be accessed by all task trackers across the nodes. All right. So let's go back and see the status of our services. Services are okay except for Oozie, which is not running. We'll have to turn it on. Now, there's something called Flume. Okay. Just now we talked about just now we talked about our structured data. Okay. There are many cases, specifically with respect to the plain text file as well as binary file, where the data is flowing from one location to another, and you have to handle that, all of that flow of the data. Okay. Database tables are okay, but when it comes to various unstructured data, it becomes very important to define the flows. Okay. So Flume is one such application. Flume was specifically designed for handling the logs in Hadoop, or handling the logs of your web server. Okay. So it started with handling the logs of your Apache web server, because whenever you run these websites, you have more than one servers running the running the running your web application, and parallelly they keep generating these logs. You want to move this log frequently to your HDFS, or you are running crawlers which are downloading data from Twitter and other sources. You want to move this data as and when it comes to your to your HDFS or Hive or wherever you want to move onto, I mean, whether HDFS or any other way, wherever you want to move, you will have to do it just like the way you do tail minus f. Tail minus f, as and when the data comes to the file, it displays it to the screen, right? So Those kind of things are very smoothly done in Flume. Okay, so Flume can be used as two examples I gave. First one, to handle your web apps data, you have multiple web application servers running, generating logs, and you need to move their logs very fast speed onto a central machine, onto HDFS, not central machine, onto HDFS. Second example I gave is that you want to do a sentiment analysis and you want to download using crawlers various data from Twitter and then move this data to HDFS. Okay, what do we mean by log? Okay, so whenever we run an application, it basically creates the errors and various debugging information, and all of this information is saved into this file continuously. Okay, so this saving of the file, saving of all the error messages, is called log generation. Okay, a log generation can be in the form of files. A log generation can be in the form of devices, where in case of Unix, you have specific devices called varlog and vartmp. Okay, and probably all languages, be C sharp, be every language provides you mechanisms to generate logs, or at least library. Every language has got libraries to safely manage the logs of your application. All right, databases has logs, right, Cletus? Okay, good. So the way, the basic philosophy of Flume is like this: you create various agents, agent 1, agent 2, agent 3. Now each agent has got three things. First is source. Source is somebody who generates the data. Okay, and second is channel. Okay, let me talk about channel a bit later. So agent has got one thing called source, other thing called sink. Sink is the final destination of the data. All right, and the channel is the memory supported queue. Right, now every agent has these three things, and these three things are connected back and forth. Okay, so source knows that this is my channel, so source puts all its data into the channel, and sink knows that this is my channel, and sink reads from the channel. Okay, and in case sink is too fast at generating the data, it will have to wait a bit if the channel gets full. Okay, so if the channel gets full, basically channel is a memory supported queue. On one end, source keeps on pushing the data into channel, while sink keeps on reading in the bulk and pushing it somewhere else. Okay, so in case sink is slow and source is faster, the channel will get full very quickly, and in case source is slower and sink is faster, channel will go empty. Okay, now this is what we call an agent, right? So there is something called source which generates the data, right? Well, who can be a source? Say a source could be tail minus f. What does a tail minus f do? It reads a file continuously. Okay, or it could be a daemon, it could be a process running at a particular port, listening for the input packets to come in. Okay, that is source. So a source is something which generates you the data, right? So let's say we figure out or let's say we launch a small services on multiple machines. Okay, and we define that all everywhere we are running 1111 port on, say, 4444 or 44444 port. Everybody who generates the log connects to this source and puts the data there. That is my source. Now from that source will take the data, push it to the channel. Now sync is continuously listening on the channel and will keep on reading from the channel and push it to whatever we have defined. Whatever kind of sync it will push the data to that place. Okay, sync might be sync might be dumping the data to any other agent's source. Okay, sync might be dumping the data to anybody else's source, which means you can chain the agents together. Which means you can chain the agents together to ensure your delivery of the logs to the final destination. All right. So Flume is essentially a distributed, reliable, and available system, and it is designed for collecting, aggregating, and moving large logs from many different places to a central data store. Okay. Now, so Flume supports a large variety of sources. Source is the data generation guy. It could be the data generation could be based on syslog daemon of Unix. Syslog daemon of the Unix has been the standard, and lots of people follow that design, where there is a daemon running, there is a process listening for the logs, and the whole system gives all the error messages or all the error logs to the central daemon or process, and it keeps on storing it whatever way we have configured it to. All right. So source could be syslog, which means if you want to gather the system logs of all the kinds of every system running you're running your machines, it will be very handy to create a source which handles syslogs. Okay, and it could be log4j. Okay, which means if we create a log4j kind of a service, it will basically help you it'll basically help you to gather logs from various kinds of servers, such as all those who support log4j. Okay, the way you have log4net library, open source library, to generate to create logs in .NET. Similarly, log4j is there for Java and other multiple languages. So earlier there was syslog. Java guys thought that they will try to replicate a similar design by creating log4j and then log4net and so on. Okay. So the design has become a de facto where logging is basically a daemon. Okay. Now that's about the sources. Flume nodes can be arranged in arbitrary topologies. Okay, which means we can have multiple sources putting the data into a channel, and we could have sync pushing the data to anybody else's source, which means we can chain them together. I'm sorry. Right. So typically in general there would be one agent running on each source machine with tiers of aggregating nodes that the data flows through on its way to HDFS. Okay, so the data goes to source puts the data into channel sync pulls the data or sucks the data and pushes it into HDFS, or maybe pushing the data to another source, and would be there will be a full chain. Okay. The important thing you should notice here is every agent has got a direction. Okay, input and output. Okay, which means every agent has got direction, and therefore they all target to reach to some point. There is a flow in a certain direction. Now let me just take an example that will be a better way to describe. And there are two kinds of delivery reliabilities. One is best effort delivery. Okay, it doesn't tolerate the node failure. Okay, and then there is another delivery reliability which guarantees deliver in node failures. Those are the two designs. Now let me take an example. You can also download it. So I'm so since those who I have given my PDF, they might be having an older version. Now in some time they will have the newer version. Okay. All right. All right. So let's try to do a Flume thing once. Okay. Now I have created already Sgiri, and then I have got Flume. Okay. Under this we have got conf directory. Okay. So let me walk through this Flume properties. What does it have? So A1 is my agent name. Okay. For the example sake, A1 has got sources, sink, and channel. Right? The name of its source is R1. We could put comma R2, comma R3, comma R4. Okay. Similarly, we could put sinks, one sink, two sink, three sink, and so on. And channel is C1, and mostly the channel is generally 1. Okay. You can also have multiple channels if you wish so, but mostly you will find only a single channel. Okay. So sometimes you might want to have a channel which is there in memory, and there is another channel C2 containing a mirror image of the data on the disk. Okay. So if sync fails to read from C1, it will start reading from C2 and try to get the data. Okay. Now we just gave it a name. We told agent A1 that the name of your sources are these are your sinks, and these are your channels. So that is first definition of agent. Now we want to describe what is each one of that. So what we say is R1's type. R1 is what? My first source. R1 dot type is netcat, and R1 binds on localhost. R1 binds on this port. Okay. So those who do not know what is netcat, you can think of it as a very quick way to create a daemon service, very quick way to create a process that listens on a certain port, so this netcat is essentially reading the data from localhost by listening on localhost at 44,444. Okay. Now next is that you describe your sink So I say my here I have defined the sync name as this. Okay. While other names are 2 characters, this one is particularly bigger. And I say that sync.type is this one is commented. Note that this is hash commented. Okay. So sync one type is HDFS because what we are trying to do is we are trying to listen on the local host at a particular port, and whatever data we read from there, we are going to push it onto HDFS. Okay, we are going to push that data into HDFS. All right. Now, and we when we say type is HDFS, we need to tell that where in what folder should it be putting the data. Okay, in what folder should it be putting the data. Now we described the sync, we described our source. Now let's describe our channel. Channel's type is memory. Okay, channel's capacity is 1000 bytes. Okay, and transaction capacity is something. All right, now once we have described these three things, we also need to tell our sources that your channel is here, our sync, this sync, that your channel is this. So agent need to know about its sync, source and channel, and source needs to know about, as you can see in this diagram. So agent needs to know about all the three people. That's what we have defined in the first section here. Okay, now we defined source, we defined all these three, and the fifth section actually, not fourth, defines that, tells the source that put your data into this channel, tells the sync read your data from this channel. That's all. Okay. All right, let's start. So once you are done with it, you run your Flume ng agent, defining a config directory. Okay, it says that the specified configuration file doesn't exist. All right, now so let me just all right, so Flume agent says, let me just fix some formatting issues. Okay, so you go here. So we have got Flume agent. So this is the command to start. We created the configuration file. That was the 0 step. This is our 0 step. Okay, and okay, step 0. We created the config file. Step 1 is start the agent. Now let's see. Okay. I need to define the folder also. The folder name is conf. Okay, folder name is all right. Now if it runs properly, that means it has started the service called netcat, which is listening on the local host 44,000. And how do you test if something is running on a particular port? Anybody? quickly, if I ask you that, can you test if it is really running on 44,444 port on the local host, what will you do? Anybody quickly? Netstat. Okay. Anybody else? Netstat is good. And if you want to communicate to this service, what you do? So PSEF is good, Netstat is good to just find out if the process is running on a particular port. But if you have to talk to this service, what will you do? Yes, Telnet. Okay. Thank you, Sanjay. Thank you, Shrikant. So what you do is Telnet localhost. All right. So it says, sorry, I'm on my Mac, local Mac, and let's just log in onto Hadoop one. All right. Now say telnet localhost, and I say, all right. Now it is connected. You can see that if I do it on another port, I'll get, say, error. It says connection refused, which means, or if I just close this service and try to connect again, it'll say connection refused, which means ours is the service which is basically listening on this port. All right. See, so it's running fine. And whenever we say, hi, how are you? So you will see that the data is getting created parallelly into our HDFS file. Okay. So HDFS file, the configuration we had on this machine was essentially creating a sink. It says sink. And does it say creating this particular temporary file as Giri Flume web data? This is where it is putting our data. Okay, so it says as Giri and Flume and web data. You can see that. And as in when we can delete this, we can delete these files. And as in when we talk to this service, again, hey, what's up? We are just fiddling around. Okay. Now it'll again create one more file. Let me refresh. Okay. So this is where it is dumping the data. All right. Hey, what's up? We are just fiddling around. It's just that it has put the data into a format called Apache byte writable. Okay. So it has to be read using this reader, specifically if you're reading from a code. So we were successfully able to communicate to this daemon, which pushed its data to HDFS. Okay. Now instead of this, there could be hundreds of kinds of syncs available, and and you can have a look at those all available syncs here. Okay, you can have a look at the syncs available at here. So there are multiple kinds of syncs, and most importantly and most neat one you will like is tail. Okay, you could define your tail, your source as type exec, the way we defined our source as type exec, and you can define that this is my command line. All right, it will execute this command on all of the nodes which are running your Flume and push it to your sink, whatever you want to. Okay, sounds good to you? All right, right. So Sanjay, as I was telling, so that example I have not prepared, but I am in the middle of it. So Flume, you will feel the real requirement of Flume in the cases where you are continuously downloading data from, say, Twitter. Okay, so Twitter provides you an API to download a sample of the total data, and as and when the data arrives to you, you want to push it to the HDFS. Okay, there you will feel the need of a system like Flume. Okay, so that's basically when we do sentiment analysis, we generally download the data from Twitter, and that day there's one example I'll be sharing with you where I'll demonstrate how to download the data for doing sentiment analysis. All right, so that is another use case you can try it out, but there are infinitely many use cases, and and this kind of Flume kind of system can be used with or without HDFS. Almost in every organizations, large organization or organization which has consumer facing services, you need to have a centralized place where all the logs need to be moved continuously, so that the people who are developers, administrators, they have a single place to look for the data rather than rummaging around hundreds of SSH servers. So, Cletus, I was talking about the sentiment analysis. We'll talk about it in a minute. Don't worry about it. So, when you talked about log4j, can it be configured? Yes, it can be configured to directly send the data to Flume's agents. Okay, or Flume's agent can behave like a source to log4j. Okay, so when you're configuring log4j, you can just mention this server, and then it will start accepting the log4j logs. All right, so moving on. Okay, great. So Cletus, your question related to, I was talking about something called sentiment analysis. Is that what you mean to ask? Okay, so in very simple words, in very simple example, you want to do what people, you want to understand, are people talking negative or positive about you or your company? Okay, all you do is find out all the tweets or sample of all the tweets from Twitter related to your company, containing the keyword of your company. And now, out of all these tweets, find out for each word in the tweet what is their value, whether it's negative or positive, using a dictionary. There are dictionaries which give you the whether a word is a positive or negative. You combine together, you sum up the each tweet, and then find out whether people are talking about you as positive, or are they talking about you in negative sense. Okay, so that's what is called sentiment analysis. Okay, basically representing word by numbers and then summing it up and figuring out whether it's negative or positive w- that people are talking about you. So that is generally called sentiment analysis, and this is the most simple case of sentiment analysis. All right. Now, the next thing which we are going to talk about is Oozie. So we have so many components. One, and we have a Sqoop, Hive, Pig, and all sorts of things we have. We have MapReduce, we have Mahout, we have whatnot, right? So when you have to run multiple things, okay, you will find the need of doing it in a chain process. You have some sort of a workflow. How many of you guys know something called JPBM? JBPM? Java Business Process Management or monitoring, I don't know. It's basically there used to be a XML kind of language using which you define your business processes. Right. Oracle uses it as well, yeah. So that was a standard JPBM. So similar to that, okay. So lots of organizations have their own BPM, business process management, where you have hundreds of services, okay, which you want to call and do kind of a storyboarding. Okay, so similar to that, Oozie provides you a language to define a XML kind of language to define the whole workflow. Okay, has so do you guys have used Maven and Make or something of that sort? Who has used or okay? So good, good. So all of Maven and all of these have a mechanism of. Let me just write in this. Okay. So they all have a dependency graph. Dependency graph. Okay. And so do you want me to explain directed acyclic graph for you? All right. All right. So whenever we say things like get ready for the office, okay, so when we say get ready for office it means a lot. Okay, first first it can be putting on your office clothes. Now what does it mean by putting on your blazer? Okay, you cannot put blazer without putting on your shirt and a certain pants, right? And wearing certain pants is and shoes. Wearing shoes depends on wearing socks, right? You cannot wear shoes without wearing socks. I mean, you can, but when you're going to office, you definitely would not, right? Similarly, wearing a tie comes after wearing a shirt. So there is this workflow. So getting ready for office involves a lot of things, right? So you can simply say getting ready for the office depends on wearing blazer, and wearing blazer depends on wearing a shirt, and getting ready for the office also depends on wearing shoes, and wearing shoes depends on wearing socks as well as wearing pants. Okay. Now now if you look at the whole graph, you will find out that whenever we say get ready for the office, you will have to do all of these things together. Similarly, in the same spirit, if you are building a software, say ship, we say ship, or you let me just stick to the wearing clothes. But if you are just going down, you can say that just wear your pants and shirt and go down, right? That will not involve wearing shoes and socks and wearing blazer, right? So all of these independent tasks can be also executed. Okay, this is where the whole graph comes into play. So it does have a XML. Okay, it does have an XML. I would love to show you. Right. So let me, do I have a nice here? Okay, so this will show you. So whenever we talk about a directed acyclic graph, it means this, all right? So here you can see that 5 needs, for doing fifth task, you need to finish 11th task first. To finish 11th task, you need to finish 10th, and so on. All right. So this kind of graph, the dependency graph, A depends on B depends on C, is generally called a directed acyclic graph. Basically, a graph with the directions, a graph with the directions, and graph with no loops. Okay. So it cannot be that for wearing shoes you need to wear, sorry, for wearing socks you need to wear shoes first, right? If that happens, then you can never get ready for the office. So most of the workflow, most of the event are essentially build up of these graphs. Okay, lots of things as you think about it more and more, you will find that directed acyclic graphs are probably everywhere. Okay. So similarly, when you say I'm shipping my software, it involves building documentation, building, compiling the product, running the test cases, and so on. While each of these units further involve many things, like compiling the product also means copying the property files from source location to the destination, substituting variables, and then compiling might also involve, you know, putting libraries into the right place and then calling the Java compiler. And once compilation is done, we might want to minify things. Okay, so all of this need to happen in a chain, in a, okay, and that's how the your Oozie also works. Okay, so when you can say that run my sentiment analysis, that will involve first download data from Twitter, copy that data, run, before doing that, start my Flume, this Flume started. Second, start down all those three commands I ran, it will do it automatically. You define all of those together into an XML and it will do it for you. Okay, now let's go back. So that was a directed acyclic graph. And there is a coordinator. Okay. Coordinator jobs are basically a workflow jobs triggered by based on time or frequency. It's like a cron job. Cron job means cron job comes from Unix, where we say that run my process at this particular period and this particular time. Okay. So similar to that, a coordinator job goes one step further. A coordinator job can be executed based on frequency or time, can be triggered by time or data availability. As soon as a particular file is available, trigger this. So that kind of jobs are possible using Oozie. And just for these kind of jobs, coordinator jobs, Oozie runs on a server. Oozie, there is a Oozie server. Okay. And Oozie is integrated with the rest of the Hadoop stack really well. Okay. Now let's have a look at Oozie. This is our Oozie dashboard. It shows that what is running, what is suspended, what is scaled, and these are the coordinators, whether they are running or not. There are no coordinators as of now. Okay. And here there is a configuration of Oozie and various properties. Okay. All right. Now these are the configurations you can see. It runs on Hadoop 2 at 11,000 port. So note that down. Okay. And let me just see if I have. All right, why does it shut down? Don't worry. Okay, so let me first take you through this. All right, so there are two ways to define your workflow. One is you go to Workflow Manager and you click on Create Your Workflow and you say My Test Workflow. You define it and then save it. Now the next step is you pick a MapReduce task. Okay, we call it MapRed word count. All right, and you say that my jar file name is this one. Downloads, and yesterday we created word count, and that's it. All right, so we call it files add path. Here before we can also define that what need to be done, and also we can define the properties of the workflow. Here the properties could be this one. Okay. Value input directory is user as Giri student, and then as Giri, and so on. So we say word count, not this one. Yeah, input, and select this folder. Okay, this is my input directory, and my output directory. Let me just define my output directory. My output directory is, let's say, user, or let me just write it. What's a big deal? User student as Giri and output Oozie. Now next property I need to define is my mapper class. My mapper class. And my mapper class name, anybody remember? My mapper class is, okay, so output directory we've defined, and we can define our mapper class, we can define our reducer class. All right, so mapper class is something to do with sg.mapper because our package name is sg.mapper, sg.reducer, and that's it. Okay, so it would be sg dot not word count, Srikanth, because sg is our package and this is our class name. Okay, I'm not sure it would work because I've not tried it before. I mostly tried with the defined workflow. So let me try to submit it. So it says it's running it and we'll see what happens. Okay, and the ID, we call it details, application path. Okay, nothing much. So is it doing something? It gave an error. I don't know. Let's just look at the logs. It says running. And here we go. So it's doing something. Okay. And we'll just, okay. In case it doesn't run, do not worry. We'll make it run in our another example. Okay. So for each one, you can see that it had generated an XML config file. All right. Okay. So is it dashboard? What does it say? All right. So something is not right. Ah, the Oozie server has shut down. Okay, okay. So Oozie server has shut down. Probably this guy is suffering. Again, the memory thing, we'll have to figure that out. All right. So I'll show you the full example maybe in the next session. Okay. Here there is something missing. Probably it is running a low memory or something. We'll move it to another machine and then test it. Although it's running already on another node. Okay. Again, it went down. So still running. Thankfully, it's not killed even in between. Okay. It's taking some time. Maybe it'll take some more time. Let's move on. Basically, it's the job ID, as in, I don't know what is it. Basically, the job which is being created in the task tracker that has got one ID and workflow has got one ID. So probably it's calling the other ID, which is MapReduce ID, this one as job ID, external ID 803 and 803113, and there is one this ID. This is 346. So this one job ID is something which is basically one given by the Hadoop, other given by Oozie. So therefore there are two IDs over here. All right. All right. Now, cool. Let me just see if something is moving over here. Otherwise, we just move ahead. Is it running or it has shut down? I think it failed. No, it's still running. What is it doing? Why it's taking so much of time? It doesn't put any output over here also. Anyway, let's move ahead and let's take a quick look at what does it mean by a workflow. So every workflow has got something called an action. Under action, there are these commands, multiple kinds of commands. We'll talk about what kind of commands are possible, just like in just like in ant or make or any other similar system. You define these commands, and each action had got these points where it says if it is successful, where should it go, and if it is finished, then where should it go. Okay, so there is a specific action called end, and there is a specific action called kill, and so on. Okay, so in case of everything is okay, then it goes to end. Otherwise, in case of error also it goes to an end. Here we could configure that in case of error it should go to some other error handling way. In case my MapReduce fails, you can do something else. All right. So those are the kind of things you can customize. Similarly, here it could, in case it finishes something, it can go to some other processes as some other work and then start doing that one. And there could be multiple actions chaining together. Okay. And there could be multiple map reduces in a single task. All right. Here, a, a map reduce word count, there is a start. If it is okay, then it goes to end. If it goes to error, it gets to kill. Okay. So those are the various workflow stages. Now, the way we had MapReduce, you can define streaming. Basically, MapReduce executes a MapReduce job the way we did. Similarly, you could define streaming job, and luckily, we have got okay. We have got okay. It doesn't kill or suspend. I don't know what to do with this. Look into this. Okay. Here we can go to, let's say, some other workflow, and we can actually add. So this is just for the example sake. So the way we did for MapReduce, we can do for the streaming also. Okay. And and once you're done with the streaming, you can uh, also define the other values. Okay, just for the heck of it I'm doing it, and here we can do add it. Okay, so basically a streaming job requires a command which is executable script or any binary as mapper and reducer, and then you can add files to it. All right. Similarly, we have Java. In case you want to run the Java program, you can give the jar name. Okay, and you can tell what is the entry point, and then you can specify the arguments. And in case you want to specify, say, memory options or other options, you can provide these here, and so on. So you can execute various kinds of nice things such as MapReduce, streaming job, Java program, pig script. You can specify a pig script. Pig script, basically you provide the script name which is uploaded onto HDFS, and all of the script data, anything you want to use in Oozie, you need to define that on HDFS. Okay. Similarly, Hive. In case of Hive, you can define your script name that this is my Hive script. And similarly, in case of Sqoop, you can define the command what you want to do. The whole command which follows the Sqoop command, you can put it here, and that's all. Similarly, you have got shell. Any command, any shell command can, or any shell script can be put here. Okay, it could be even things like wc, grep, or anything you want to do. If you have a chain of commands, you can put them in a script and put that script here. Okay, now similarly you have got ssh remotely. If you want to do something, you want to say pull the data using scp, sorry, you want to execute a command, say kill some process on some other server, you can use ssh. Okay, ssh not only logs you onto one server, it also helps you executing a command on a remote server. Okay, so if you say ssh user at the rate server and then you say ls, it will basically do the file listing on the remote server. So that helps you in a lot of automation on the server related stuff. Okay, using ssh you can control the whole of your cluster, right? Disk cp is that hadoop disk cp. Similarly, fs is hadoop fs. All those commands you can specify, right? You can specify what action you, what you need to do, whether you want to create a file, delete a file, move a file, and so on, right? So delete a path, what path do you want to delete? You want to create a folder, you want to change the mode of the file, we want to give the permission and all, or you want to touch a file. So all of this basically you, whenever there is a data flow, you require these stages and you require these things to happen in a flow. So as well as you have, like with anything, anything is not complete without having an email. And we have got an email here, so you can send an email in between that we are finished with copying the data, we are moving ahead with our work. All right, so that's it. So you can also do a sub workflow, as in you have already defined your workflow as part of another program, just like we have defined my test workflow here. So we can execute that workflow here itself. Okay, just like in case of ant, you call the another ant script from one script. Similar is the case of sub workflow. Okay, and in case none of these is sufficing you, you can create your generic one where you can specify the whole XML the way we had defined our XML here. We can just copy paste this XML and put it here. All right. So the generic is quite frequently used. All right. And the way we are creating the whole thing using the UI, if you have created an XML, and you can use the Oozie command to schedule your XML onto the server. Okay, like so, you can say Oozie and define your job. Define the Oozie server. This is my server on which my Oozie is running, and then you can define a config. What is your job properties? As an example of job properties, I'll show you. All right. So a job properties is that, okay. So it contains all the parameters which you are trying to pass to our MapReduce. All right. And then you can say run. And you'll have to define a XML file also for running any example. All right. So here is your workflow of the MapReduce. and you can see this is the workflow which we are trying to execute, and you can submit this workflow from the command line. All right, number of tasks, how many things you want to do, what is your input directory, and all that. All right, so all of this can also be done using the Oozie command. All right, let me show you again this. All right, here this is not correct, and this is my application workflow path where my XML is located, and it will move it. All right, now, so these are the various things we also talked about. You can have a look more at Oozie, and also one demo of Oozie is due on me. I'll be doing the demo of Oozie maybe in the next session. Till then, let's move ahead with our Mahout. And and by the time you finish Mahout, clarity. You will get a clarity on where all we can use our Oozie, right? Because when you talk about Mahout will involve at least two commands. One for gathering and cleaning up the data or copying the data, and other executing Mahout. Okay, so that's where you will feel the need of having the workflow. All right, so a Mahout is essentially a scalable machine learning library built on top of Hadoop and is written in Java. Okay, so it started with the Hadoop, and now it is compatible with a lot of other similar systems, and it even runs independent of Hadoop. Okay, it's essentially written based on an Angie's paper. There was a paper called MapReduce for Machine Learning on Multicore, and it started as the sub project of Lucene, and afterwards it became the top level project in of Apache in 2010, which is 4 years ago. Okay, and Mahat is a Hindi word which means it's a keeper or the driver of elephants, right? Yes, you are right, Naveen. So if you have exactly, so I forgot to mention that part. So in case you have two map reducers in which one finishes, then you make a copy of the output of the file and put it somewhere, and then you run another one. Or even if you don't copy, you just start with the whatever reduce produced. So all of those things are fairly possible. So in those cases, you will have two map reduces action when okay to go to the next action. All right. Okay of the first one will go to the next action. Now, all right. So what is machine learning? Machine learning is basically feeding a lot of data to computers and let computer figure out. So these are machine learning is a branch of computer science which deals with computer themselves learning a lot automatically based on our data. Okay, so we train. It's a branch of AI, artificial intelligence, and it helps in design and development of algorithms, and based on the idea that computers should evolve the behavior based on empirical data. Okay, in the most simplistic case, if let's forget about all machine learning for a minute, the extrapolation of the data by plotting a graph and doing a future prediction based on that graph has been there since ages. Okay, it is just that machine learning takes that to a whole new level and gives you a very high precision results after understanding a lot of data, and it delivers the output at a very fast rate. Okay, now there are three kinds of machine learning. One is supervised learning. Okay, in supervised learning we concretely label our training data. So all machine learning has a training data, and based on that training data, the algorithm learns and then starts imitating you. Okay, so first one is supervised learning, in which we concretely say or concretely label the data and feed it to the machine. We say this is the spam, this is not the spam, this is the spam, this is not the spam, and so on. We feed all of this kind of inputs to the machine, and after a while it will after a while when you feed an email, it should be able to concretely say that this is the spam or not. Okay, to do that we do a lot of things. We create a classifier, we define the classifier in terms of various words encountered, and so on. So that is supervised learning. Second part is the unsupervised learning one. In unsupervised learning, okay, the data is fairly unlabeled. Okay, the data is fairly unlabeled, and we on this unlabeled data we create a function that can predict the output. Okay, and I mean, basically we give the classic example of unsupervised learning is, given a lot of data, just classify it automatically into 5 buckets. Okay, so we haven't given any label or anything, we have just told that this is my input data, just classify into 5 buckets. Okay, and we will think about the labels later on after we have the buckets. Third one is semi supervised learning. Okay, we make we make use of unlabeled data for training, typically a small amount of labeled data with a large amount of unlabeled data. What does it mean? We have only very minor indications of labels, and using those labels we try to figure out various kinds of detailing. Say for example, we look at image we look at an image and we try to predict whether it's a cat or a dog or whatever it is, and we have only minor hints, may be available, may not be available, such as the name of the file. Okay, say I mean that's I mean name of the file may be available, may not be available, because on world wide web people might give a correct name or not. So that is semi supervised learning. So maybe 10 years ago, the machine learning did not have much of application. Specifically, why? First, machine learning required a lot of training data, which means millions of records or maybe hundreds of thousands of record. Only then it is of any use. Only when you have that kind of records, only then it gives you a decent amount of output. Okay, If you have 10 records, or if even if you have 1,000 records, you won't be getting any sensible output out of the machine learning. All right. So so these are the few examples of machine learning. So first one is recommend friends, date, products to end user. This is like far more popular than any other. Second one is classify content into predefined groups, okay, such as your Gmail inbox. Third one is find similar content based on object properties, meaning you may also like this, or people who like this also like this. Identify key topics based on collection of text. What? Basically, what Google News does. Based on the collection of text, it figures out what is this news about and accordingly correlates with other news articles. Detect anomalies within given data. Okay. So when we know that genuine data looks like this, and this is the data which is coming in, it should be able to figure out that there is something wrong with this data. Okay. And that's used generally in firewalls and generally in other similar kind of applications. So computer vision, natural language processing, bioinformatics, speech and handwriting recognition, and search engine results, and I mean there are various kinds of user feedback learnings also, where we see that this person is clicking on this record based on the recommendation. Okay. So these are the few applications of machine learning which are into a lot of into a lot of use right now. Okay. So when we talk about machine learning tools, because when you meet people, they anybody who is programming in even Excel might claim that they are machine learning experts. Okay. So if you have few lines of data, okay, if you have few lines of data for analysis and visualization, your whiteboard in office is good enough, or pen and paper is good enough. But if you have kilobytes to megabytes of data, okay, up to lower megabytes means 20 MB, MATLAB, Octave, or R is good enough. Okay. M- But in case your data is bigger than MBs and in low GBs means say 30 GB, 50 GB, and so on. And in those cases, NumPy, SciPy, these are the libraries provided by Python, and other libraries are good enough for analysis. And you might require Flare, mcharts, and Raffle to do the visualization for you. While if your data goes beyond gigabytes, up to terabytes or petabytes, you don't have a visualization tool. For visualization, you will have to represent this data into a smaller statistics. Only then you will be able to represent it. Second, for analysis, you would require something like Mahout or Giraffe or MLlib. This is MLlib, not MLib, MLlib. Okay, machine learning library from Apache Spark. So a recommendation example is this one simple example where there are reviews. Person A likes a particular movie and has given a particular rating. Now, based on this, can we give the recommendation to these people? Just based on this, we don't have any other attribute of these people. Neither we have the attribute of Sandeep and Kumar in this example, nor we have the details about these movies, like who are their directors, who, when was the movie launched. We don't have those information. All we have is this. So can we generate the recommendation for these users just based on this? Okay. Now let's just move to the next sessions before we. All right. So for this, first download this data. Okay. Let's download this data. I have already downloaded it. For the example which we are talking about, we are trying to generate recommendation based on three columns: user, movie, and how much this user has voted for this movie. Basically, we are trying to generate the recommendation based on this. How is that possible, first of all? So you will have to figure out the similarity index between various users, and then you start cross selling. So movies liked by Sandeep may be useful to Kumar. And first we have to figure out of millions of users that these are the similar users. Eh, Okay. So your life is actually simplified by Mahout, because for Mahout, if you are using any of the recommendation examples, all you need to do is prepare comma separated file with these three columns, and that's good enough. All you need to do is prepare a file with three columns, okay, containing some ID of the user, some ID of the product, and some ID of the rating given by this user. And it will give you the recommendation for all the users. I'll show you how. So first, if you want to download it, you can download this movie lens data. Movie lens contains the recommendation from the website called Movie Lens. Download it, unzip it, and then you start. First, you convert this data into. All right. So let me. I have already downloaded. Okay. So we have in my folder. I've already downloaded this. So this essentially contains my movies. Okay, these are all the movies, and then we have ratings. Okay, so not this one. This is already ready. Okay, so this is our movie ratings file. Okay, all right. Now we have got this ratings dot dat. We want to convert. We want to convert it into comma separated one. What will be the best approach? Anybody? And we want only first three columns. Okay, good. And we are only looking for the first three columns. That's all. Cut. Okay, good. SED cut. Excellent. Anybody else? Arc. Excellent. So basically we need to convert the ratings available to us, which we downloaded from Movie Lens database, is in this format. Double column separate. So first one is user ID, movie ID, ratings given by the user to this movie and on what date. This is the date, the fourth one. Anybody? How do you convert this file to comma separated one? Other than Avdesh and Vishal? What we want is from this file, we want to convert it into this format. Okay. This format into this format. Yes, yes, regex. Okay. So can anybody mention the pig also? We can actually use pig in case this file is bigger. We can use the pig in the sense that run pig, load this file using pig loader and mention colon. So if we say pig and let me just run it locally. Pigx local and I say my data equals to load ratings dot dat using pig loader could not resolve pig loader. It was pig catalog or pig loader. Oh, it was pig storage, right? I forgot completely. Okay, now you can out of D. Now what you can do is you can project on a new data for each D and generate $1, $2, and $3. Not $1, $2, $3, $1, $3, and $5. Yep. But the pig storage only take a single character as the separator. Uh, all right. So try to do that. Okay. I'm just so right now I have all I did was I did this and generated my ratings.csv. Okay. All I did was did awk and generated my yeah. Yeah. So Vishal is right. Instead of referring it 123, I'll have to refer 135 instead of that. I should have referred it $0, $2, $4, and that's all. And then using pig storage, when we say store my set into one particular file using pig storage, and then I mention comma, and that's all. And we'll get the rating.csv. There are multiple hundreds of ways. So once you have got rating.csv in this format, so where did it go? It is, where is it? Okay, ASCII, and I say 1 million, and we have got ratings.csv, right? Now in this, once we have done that, we'll have to copy it to our HDFS. Okay. And after that, once you're done with it, you can run, it's already there. I have already done it. Okay, it should be somewhere. Yeah, ratings.csv is there. So ratings.csv, after you have done that, you can execute the recommendations. Okay. Now the output is going to be in recos and will take a lot of time to run. And at the end of it, what you need to understand is that at the end of the whole process, you will get, okay, you will get recos. Okay. So what is it saying? It says the output already index exists. And let me just delete this. What is the date today? 14th December. So yeah. So after you have run it, the output you will get is in one of the folders called, what does it say now? Once you have done, you will get the result in this format. So you didn't have to do anything. All you had to do is prepare your input in the format user ID, product ID, and rating. And in the end, you will get this. You'll get the recommendations. Okay. So you can also specify how many recommendation you want per user, maximum recommendation per user, and it will give you only that much. Or you can also define that up to what rating you want it to be displayed here. So this basically says for this user, this product is recommended and this much is the quality of the recommendation. Same is this and so on. Okay. You can take this file and put it on your web server where, or you can move this data after loading. This is basically, you can see it's a, first one is one value and second one is, it's a tab separated value, so it can easily be loaded using pig, and you can format it in whatever manner you want to format. Maybe you can use a pig storage of JSON and output it in JSON format so that your web application server can load it and serve it to the users. For this user it needs to display these recommendation, for this user it needs to display these recommendation, and it can do that. Okay, does it make sense to you? Now what is the problem with this guy? Okay, okay. This already created some sort of temporary data. Alright, it'll take a lot of time to run. So there are other algorithms in Mahout which we can use, and they have their own use cases. You should look at the other examples of Hadoop, sorry, Mahout, where all other algorithms are mentioned. just for the recommender. What I want to emphasize on this particular command, where we have said that Mahout recommend item based. This particular example where we are recommending movies to the users is item based recommendation. And then we are telling that use this particular algorithm for movies. Okay. There are other algorithms, you should go through them, go through them and understand when to use which one. Okay. This is my input file, this is my output file. Sounds very simple. Internally, Mahout basically gives the data to all the nodes, and internally Mahout is actually calling Hadoop MapReduce, and scheduling its work. Right? Internally, that's what it is doing. So this time, what was the problem? All right. So let it run. Let it run, and it'll take maybe some time, some more time to do things. All right. So using a simple command, you were able to generate recommendation of this form, of this form. All right. And that you can basically also convert it into JSON or any other format. And in case you want to further customize Hadoop Mahout, in case you further customize Mahout, you can, instead of calling Mahout from command line, you can write your Java program and call Mahout's library as if it's a function. And in return, instead of giving you this rigid format of tab and this kind of a format, it will give you proper object format, okay, which you can present in whatever manner you want to do. All right. So that's pretty much for today. That's pretty much for today. In the next session, we'll look into Spark and few more examples. All right. We'll look into Spark in detail. As well, we will run through an example of Oozie. As an exercise to all of you, you should try to run Mahout in your own free time. Okay? You should try to run Mahout in your own free time. As well as you should try one example of Flume and Sqoop, as well as Oozie. Okay? Try to run one example of Oozie, Flume, Sqoop, and Mahout. Okay? That's all from my side today, and let's see you to next week. All right? Good night. Have a good day. Yeah. Have a great week ahead. Bye bye.